Coming up next, I talked to David Weinberger about his book, Everyday Chaos. It turns out that AI and machine learning are making things so simple for us, but we just have to give into the chaos and not worry about the explanation. All that and so much more, including chicken sexing, next. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
This is Triangulation, episode 413, recorded Friday, September 6th, 2019. David Weinberger, Everyday Chaos. This episode of Triangulation is brought to you by ZipRecruiter. Hiring is challenging, but there's one place you can go where hiring is simple and smart. That place is ZipRecruiter, where growing businesses connect to qualified candidates. Try it for free at ziprecruiter.com/triangulation. Hello and welcome to Triangulation. This is, of course, the show where we talk to the smartest people in the world about the most important topics in technology. I'm Mikah Sargent, and this week, I am very excited to talk about this here book, Everyday Chaos, by David Weinberger. David Weinberger, you have a billion trillion titles. You have done quite a lot. I described you as a futurist, but I mean, you have worked in I'm just looking at the back page here, and you've done so much. You are the writer in residence at Google before, senior researcher at Harvard's Berkman Klein Center for Internet and Society. I mean, strategic marketing VP. You've kind of covered all of these different subjects, and I'm curious. Well, first of all, hello.
Hello, Micah.
Happy to have you here. How have these different jobs that you and these different roles that you have taken on kind of informed the book that we're going to be talking about today?
So, in one sense, my career path, which is neither a career nor a path, embodies a lot of what I'm living the life the book describes, and not on purpose. And I think it's true for most people as well. A bunch of stuff happens, and something else happens by accident. And somebody that I am privileged to know, and I mean privilege in the political sense, not simply in the honorific sense. I head this way instead of that, fall into this instead of that. There are a couple of things I think are constant is too strong, but that are fairly constant. One is that for better or for worse, I seem to always have been interested in ideas. So my academic background is in philosophy, which was a very long time ago. I stopped teaching philosophy in 1986. So the fact that I have so many titles is really just a sneaky way of saying I am very old. So, that still informs a lot of how I don't know why I'm just interested in that side of life. And I guess the other sort of permanent thread is that I'm a writer. And one way or another, I've always been a writer. For me, I like it as a craft. I like trying to get sentences to work when occasionally I do. Other than that, it's a series of mainly very happy accidents. I've been very lucky and very privileged.
So you started out with philosophy, correct? Although, what was it that it was called at the time? I was fascinated by this. You majored in what was it?
Okay, so I went to college in 1968 to 72, so sort of prime hippie years. And so I majored in meaning.
I love it.
Yeah.
I love it. You majored in meaning. And one of the things that, when I was reading the book and I kind of saw that, I thought, okay, no slight to philosophers, but I thought that this was going to be super heavy, difficult to digest. And all credit to you as you're talking about writing sentences and making them work. This book is so easy to digest and to take apart and to understand. So all props to you on that.
Yes.
I think anybody could pick up this book and really get something from it. Is that something that you feel like you've gained over time, or is that something that you sort of had from the get-go while you were majoring in meaning?
I was pretty high at the time, so let's start with that. It was the 60s. I like to think that I've gotten better at the craft. So it is something that I've worked on. I mean, I want to be understood in what I write. I mean, and that's not always easy. So it is. If I were a woodworker, presumably I'd get better at woodworking over time, and I think I've probably gotten better at writing over time.
Absolutely. So yeah, let's talk about this book. It's the idea that we have all of these complex systems now that kind of are available to us. And I have to go back to, there's a line in Pocahontas, the Disney movie, and she questions, how can there be so much that you don't know? And I kind of felt that theme throughout this, because we're just now getting to a place, it seems, where we don't know what we don't know, and we kind of have to let this technology inform that, because no matter, and I'm curious to hear your thoughts on this. It seems like humans, even whenever they say they're thinking outside the box, they're still kind of stuck in a box. Yeah.
Yeah, and except for big gigantic idiots, we've always known that we don't know as much as there is to know. I mean, you have to have a really sort of cement head to think, well, I or even humans, we know all there is. We got it down. And throughout Western culture, anyway, Western history, no, we've always known. We have always had some degree of humility, but we've had the idea, I think, that it's more or less temporary, that we work our way towards more and more knowledge, that the universe happens to be based on principles that the human mind is able to understand. I mean, it's sort of the beginning of and the book is contained within Western culture. That's its box, so to speak. But from the beginning of Western culture, from the religious beginnings and the Hebrews and the philosophical beginning with the Greeks, we've had this idea that humans were special in how we were created. And we were created one way or another so that our minds sort of correspond with the universe. We happen to have the minds, or God created us so we would have the minds that are able to appreciate some of creation. And we can do this because we've assumed that creation is the universe is it's based upon simple principles. I mean, it's huge, it's complex, of course, but there are basic governing principles, and they happen to be principles that we somehow are the ones who are able to understand. And that's been our place in the universe, and that's been our role as humans. Our essence is to be the creatures that can understand the universe that we live in, at least to one degree or another. And so that's given us the courage to go ahead and keep trying to understand things. So we tried to understand them overall. What I'm saying is itself a huge oversimplification, of course, but overall by oversimplifying. By focusing on the commonalities, the universal rules and laws and principles, and paying less attention to the particulars. The particulars are sort of accidental. What matters is that we can get a grasp of these big general rules and principles, and that's worked out really well for us. Right? We are the dominant species on the creatures on the planet. Although, of course, now that's turning out to be maybe not such a good thing, but it's worked out quite well for us. And that's allowed us to focus so much on the generalizations, on the simplifications, and to pay less attention to what the world is actually made of, which is dust that's combining, recombining, and at every instance, every mote of dust is affecting every other mote of dust all the time, everywhere.
Yeah, and so
that's bigger than us.
Exactly. We've got this idea that although we've come into existence and have tried to give meaning to something, do you feel like this is something we're just now learning because of the complex systems that we've started to create, or have we seen different philosophers and scientists and researchers and folks who have come to understand that everything is chaos?
I mean, sort of the fundamental. So. I think there is something new in this, but I want to talk about the old for a second. And what's new is that now we have technology that enables us to to acknowledge the vastness and complexity and chaos of the universe in a way that we couldn't before. So everybody knew the world is chaotic. You never know what's going to happen. Tons of accidents and things like that. But that seemed to be just not as important as the eternal truths, right? I mean, there were eternal truths that we could know, and that's where we focused. Now it's sort of ironic, I guess, that now that we have the internet, which puts this swirling chaos right in our faces and enables us to succeed with it. I mean, much of what we love about the internet and the positive ways that it has changed our lives is by showing us, letting us live successfully in a huge and hugely chaotic world. And now we have machine learning that, now that we're in some sense, used to this chaos and this overload, gives us a model for mastering. I'm sorry to use that word, it's the wrong word, but it gives us a model by which we can succeed with the particular, with the details. Sort of skipping over the process of trying to derive the generalities and even the explanations of how the machine learning is working.
Yeah, so there was, in the book, there's an anecdote about how Barack Obama's campaign was doing some A/B testing. And for folks who don't know, it's, providing multiple different almost random changes and then with a random group and seeing how it affects the outcome of whatever thing you happen to be doing. So changing the way that a button looks or something like that. And so with its A/B testing, it was just the change of like how a video was beaten out by an all text message. And I immediately was going, I want to know why that happened. And kind of in this book, you're saying we might want to know why, but it's almost not necessarily important to understand why, and more important to, depending on what you're after, the fact that it just happens that the second thing works. And is that kind of we're sort of getting past, or we need to get past explanation and look at results? Is that kind of the thought here?
Yeah, I mean, it's that we are succeeding in many instances, not all, by not even looking for the explanation. A/B testing, I think, is a really good example of this. The prior way of doing it, far prior, in the 1950s and 60s, a lot of money was spent in advertising, coming up with basing ads on Freudian principles. Sigmund Freud, and it's all. Have broad principles about how the mind works, sex and death and guilt, and so you would have laws about that, or sort of rules, which and you would apply them and build your ads, build your commercials out of them, because you would think, well, we know through Freud that all men are desperate for sex, basically. So basic drive and for control and mastery. And so we will put Freudian symbols into our ads. So you had a lot of cigarette ads that would emphasize the length of the cigarette in case you don't get it, And so that's a type of principle-based where you think you have an explanation of what motivates people. Turns out it's not right. Nevertheless, many, many millions of dollars was spent in about a decade of this type of advertising. With A/B testing, you get the exact opposite, which is, as you say, you put up two ads, in the case of Obama, two different layouts of the homepage. And one of the instances, in particular for Obama, was that they swapped out the color picture of the family that was on the front page and put in a black and white picture. Mm-hmm. And the black and white picture drew tremendously more. It was not marginal. Usually A/B testing is just sort of marginal 2% results. This was huge. I think, counterintuitive, right? You say, no, you'd like a nice color picture of this beautiful family. And black and white just drew many, many more clicks and more donations. And nobody cares about why. Or nobody said, well, hold on, I'm not going to put in that we're not going to swap out that ad for the black and white one because that makes no sense until we know exactly why. No, why? No, it works. It works basically in a free change. It works. Yeah. It works in that instance. Mm-hmm. And if McCain, who was the opponent, had done the same thing, perhaps there's no reason to think that it would work for him. It's some confluence of maybe very small and distinctive and unique to this campaign and this candidate and his family that made the black and white image work way better. We don't know, and we don't care because it's so cheap just to run another A/B ad. I mean, it's the same thing if you're doing A/B ads for, a barbecue grill or something, and you do the thing of, well, try it with a red background or a green background or model on the left or model on the right. One of them draws 2% more. Good, great, it works. We'll go with that one. And now you want to do not a barbecue, but an oven. You do not generalize and say, oh, you know what works? Model on the left worked for the barbecue. It's got to work for the oven. You say, no, let's do some more A/B testing. It's obviated the need for principles, and suddenly we don't care. And we think maybe this has freed us to think maybe there aren't principles. Maybe it's so particular to the product, to the day, to the news, to the weather, to what's been happening in people's lives, what TV show they were watching, whether they came from a page that had a big alarming headline or a small comforting. Doesn't matter. Mm-hmm. It has freed the success with this type of non-explanation approach has freed us from the sense that, oh no, we need explanations. That's the only way we need explanations. That's our job as human beings, is to understand this stuff. It turns out the instant that we don't have to, we're really relaxed and very happy with it.
And it's almost impossible, I think, for us to be able to, well, it is impossible for us to be able to put A, B, Z, X, Y, all of these things together to understand what it is. And that's why, we've got these systems that do it. You talk about the black box diagnostic system and how you can put in someone's case file for their health, and then it beep, 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 boop, and spits out a little receipt. And the receipt says, you should really get this preventative surgery. And then you take that to your doctor, and your doctor's like, look, I've studied for years. I'm smart, but I don't know why it's telling you to do that. But it's been right in XYZ case, so maybe you should get this preventative surgery. That is fascinating to me, but also, I don't know, is it, as humans, we kind of want that control and that understanding. And so I'm curious, do you see this being the future of medical health and how, or medical, the whole medical industry, and how do we get there from where we are now, where, the doctor tells us one thing and we say, so tell me more about this, doc?
Yeah, so this is a really critical question. I suspect it won't be that we will do tests at home and take them into the doctor and say, the doctor, I need this preventative surgery, because that's a little bit like going in and saying, doc, I saw a commercial on TV for this new drug. It sounds great. Give it to me. And the doc, not going to pay attention to that. I think it's more likely. So do I think it's the future? I don't know. You call me a futurist. I don't, because I have no idea what's going to happen. That's fine.
Fair.
I don't know. But it certainly seems that these systems already, in some instances, can diagnose the onset of diseases, can predict the onset of diseases or diagnose diseases better than humans can. At least in some instances, and that list is not getting shorter, it's getting longer, and the systems are getting better. So we can imagine that the doctor will, the hospital, the clinic will be using one of these systems, and it will tell you, the doctor will tell you at your checkup, well, everything looks good except the AI. Give it we'll have a nice name for it, for that particular system. It says that you have a 78% chance of getting type 2 diabetes in the next 5 years, and you'll say, but that's nuts. I exercise, I don't eat sugars and so forth. Why? And the doctor's going to say, well, it's a really complex system, and it's so complex that we can't figure out exactly what it's looking at, because it's actually looking at some vast array of factors, which may be very small. Each may have a small effect, and it's how they combine, and they combine differently. We don't know. Let me put it like this. We don't know. And you say, well, then why should I believe it? And the doctor says, well, because so far the evidence is that if it says 72% chance, then it's probably right. It has been field tested, so to speak. And for some stuff, like the doctor says, you maybe should drop 10 pounds or whatever. You'll say, yeah, okay, that. No harm done, right? It's relatively a lot easier than surgery. So, and you'll do it. It's in cases where, for example, it's preventative surgery or something really costly at a personal level that you're going to be much more careful about it. Over time, it seems quite plausible to me, as these systems prove themselves out, it'll be really pretty similar to the situation we're in now, where the doctor says, forgetting the AI, says, looks like you should have the surgery or whatever, or you don't go back and do the original research. Right. And the doctor probably doesn't tell you about the original research.
Right.
The difference, of course, is that the doctor could go back, or maybe already has gone back, and look at the research and figure it out. In the case of AI, there are at least some instances in which the doctor can't figure it out and the computer scientist can't figure out how it's coming up with what turn out to be accurate diagnoses or predictions. But from the user point of view, from patient point of view, we take things on faith is the wrong word, but based upon experience. And if these systems show themselves to work, why do you trust the routing software in your phone? Presuming you do. I do. I'm totally dependent on it.
I know because it works. Yeah.
Yeah. I mean, I don't. Then how does it come up with that? I don't know. It's machine learning. It's AI, right? Don't know. Don't really much care.
True.
I don't care as long as it's working. That's somebody else's problem, and if they can't figure it out because it's too complex, too many factors, as long as it's getting me there and it's routing me around the traffic jams and the rest of it, I think this is exactly the same situation as with A/B testing, right?
Yeah.
No, we don't know why, but we don't need to know why because it works.
Well, and I was going to actually.
I want to put. Sorry, I just want to put in a marker before the angry tweets come, and they're right. I mean, there are situations in which the inexplicability of some of these systems has enormous and potentially enormously bad effects on things like fairness and bias. Mm-hmm. And that's something we should talk about. But I am aware it's a very serious problem.
You heard it. So before you send those tweets, although they've already sent the tweets is the thing, then they'll hear this part and go, oh, darn, I already sent the tweet. But speaking of that, one of the small examples that I think of, and I'm curious if this is a true example, is when I am a person who 100% of the time I put in, hey, GPS, get me here, and I follow it 100% of the time. It may look like it's a weird route. It may say, go this way. I plug my ears when someone is saying, no, we're just going to, no, I don't take your route. I take the route that the GPS is telling me. Is that an example of this sort of trusting the machine to understand in spite of what might be sort of our understanding? I don't know if that sort of fits into this everyday chaos theory, but I'm curious if you think it does.
Well, so it does in that, yes, it is a case of our following the directions of our new robot overlords without knowing how, and without, in some cases, not even being able. We will never know how. And routing, I don't think, is at that level of complexity. I may be wrong about it. But in other fields, we do it, and if we wanted to know why, literally nobody could explain it to us. It is an example of that. The fact that we do it without knowing that underneath, that we're all carrying around these, hold up my empty hand here where there should be a mobile phone, that we are all carrying in our pockets massive amounts of machine learning driven apps and information, weather reports. But we don't know that it's machine learning based, right? I think most people don't know or care that the weather reports weather predictions are now, it's AI, it's machine learning. Means that we're getting acculturated to the products and the presence of machines based on chaos, on accepting chaos. So let me say what I mean by that, if that's okay. Is that okay?
Oh, absolutely, please, yeah.
Okay. The old way of predicting weather, which is just as an example, because it's the same thing for predicting your annual sales off a spreadsheet. It's exactly the same thing. Was that you would write a program which is based upon you identify what the factors are that affect weather or quarterly sales or whatever the domain is. You identify those factors and you identify their relationship. So for weather, it's that cold air, when it meets moist air is likely to cause precipitation, which is sort of general rule, right? Or in business, it's you subtract expenses in order to get revenues. Take the world's simplest example. So you identify the factors and their relationships, and then you build a model out of that, a program, and then you run data through it. It works pretty well. And we did weather for a long, long time that way, for the past 100 years. But we also know, all of us know, that things are generally way less predictable than that. If they weren't, weather reports would be dead on target all the time for the past 100 years. It's hard to figure out what all the factors are, because everything on the surface of the Earth affects the weather to one degree or another. I mean, literally everything on the surface of the Earth does. And that's a lot. And we don't pay attention to that, right? We haven't paid attention to it. We just look at the big masses of air and the big principles. Now, with machine learning, it works differently. You don't put in the general rules and principles. You do, in some sense, figure out what the relevant factors are, because that determines what data you put in. But you just take tons and tons and tons of data, historical weather data of temperatures and air temperatures and movements, and everything you can find, or in business, all the sorts of business information and data. You put it in, and the system iterates on it, and it finds correlations among these millions of little pieces. And each of these correlations has a probability, has a weight, and you end up with a neural network, and the type of, I think, most important AI at the moment. You end up with a neural network, which is just this connection of all these dots and nodes and all of their weights. If you look at this mass, gigantic mass of points and connections, we can't figure out why they work at that level. And it may be that we can't come up with generalizations about it either, that are what we call an explanation. This means that we are able now to we don't have to simplify the data or simplify the model, the way which pieces matter and how they connect. We don't have to simplify that anymore, at least not to any great degree. We can allow as much complexity as the machines handle. And it turns out, and this I think is a revolutionary change, it turns out that you find, at least in many instances, you find more, you can make better predictions and do sort of classifications of things more accurately if you don't try to reduce it to the laws and to the factors that you, the human being, think are important.
Wow.
If you feed in the chaos, you can get some type of order out of it, and it's actually reverses the entire history of Western thought.
Yeah,
that's how you do it.
You give into the chaos. It's sort of, instead of us taking a funnel and sort of putting the weather down into it and then coming out with these small things that we can then use to calculate, we're sending it up and spreading it back out and then sending it to a machine learning. And I just want to double down on this point so that everybody sort of understands what you're basically saying is day to day, we are, in most cases, most people are checking the weather. We are interacting with machine learning day to day, and it is a direct example of how, when we give ourselves over to the chaos, it almost makes it less chaotic for us day to day, because I know when I need to take an umbrella to work.
Yes. Let me give you. I'll give you a quick example, and then I want to connect that to the internet, because I think there's a very similar lesson. The internet has set us up for this lesson. So another example is spam filters. For those of us who still use email, which I understand there's a generational divide here.
What's email again? No, just kidding.
Yeah. It's a thing you get from your father or grandparents.
Gotcha. Okay, with all of the forwards. Yeah, definitely.
Yeah, and the jokes and the bad
animated
science.
Images, yeah.
Mm-hmm. Yeah. So spam was supposed to kill. It sort of at the end of the beginning of the 2000s, a little before that. Spam was a terrible threat to email. How is email ever going to survive all this spam? And it turned out what I will not quite accurately call an early type of machine learning. Said, here's what we have been doing, which doesn't work that well. Which is, we try to figure out what words show up in spam and what phrases, and certainly what addresses they come from, and then we filter those out. And you get some measure of relief from that. But suppose we said, let's not do it that. Let's not try to figure out everything about a spam that's character. Let's just feed in as much spam as we can, known spam, as well as stuff that we can identify as not spam, and let's let the system try to find not just single words that show up in spam, but also the relationships of words and their arrangement. And it turns out it develops really, I'll call them rules, that's fair enough. It develops its own pattern recognition. Mm-hmm. And the patterns can be really complex, but it works much better. And email continues to work, which is why you are still getting these stupid birthday greetings from your parents through email. The way that one of the ways that the internet set this up is that around the same time that spam was supposed to kill the internet, was supposed to kill email. What was supposed to kill the internet was information overload. That was the main concern when the internet first went public in the early 90s and the web happened and everybody started getting excited about it. The fear was, oh my God, information overload. How are we ever going to deal with this information? And I don't hear that hardly ever anymore. It seems to have been a problem that we grew out of. And instead, there are other sorts. There's fake news. There's lots of information problems. I mean, there are issues, obviously, with fake news and also lots of problems on the internet. But being overloaded is no longer really a concern, I think, for most of us. We like the fact, we are comfortable with the fact that there is way more there than we will ever get to. Yeah. Because it means we can discover anything that we want. And so we got a culture, and it's a resource. We got used to the idea that we flipped the model culturally. There's thousands of years of thinking the way to do this sort of thing, of when you have too much stuff, is you filter it before you start to store it. All right, so because your photo album, your parents were physical photos who were maybe grandparents at this time who were worrying about what photos to put into their album. And they'd spend time going through and they throw out all the ones they didn't like, and they're throwing away information and maybe what were some pretty good shots and stuff that might have turned out to be interesting if they'd kept them. But they made the best judgment, threw them out, put the rest in an album. They filtered on the way in, right? And then they threw out what didn't fit. And we've been doing this forever. We do this every time you build a library or store deciding what to sell, because you have to, because it's physical stuff. On the internet, we pretty quickly figured out as a culture that we don't have to do that anymore. We can put everything in and let people filter on the way out. Let them discover, give them good tools to search and filter, and people will filter on the way out. And this turns out to be, you're no longer throwing away information. All the stuff is there. And at some point, somebody's going to come along and they're going to want that photo that nobody thought was valuable, or that old page of a catalog that now turns out to have this historic interest. So we filter on the way out, and we no longer have to throw away information. So we've gotten so used to overload in part because we see the value of it. This I think, has trained us for the age of machine learning, where that overload turns out to hold the key to better routing, better weather, to medical advances, to you name it. I mean, every day there's something else that shows up in the news that AI can do that doesn't seem possible, and often we can't understand how it does it.
Right. You talked about Halley's Comet in the book, and the calculations involved with determining when Halley's Comet was going to come around again. And there's a 3-body problem, and then it turns out there are several more bodies involved, and all of these tiny little things, and an alien butterfly that flaps its wing and changes the direction of Halley's. All these things that may apply. And thank goodness when they were doing these calculations, 2 calculations that were incorrect ended up canceling each other out, etc. Yeah. But with those calculations, that's a certain level of filtering that had to be done in order to write all of this stuff out as they were going through and trying to figure it out at the time. And now, instead of having to write down those calculations and determine them, we just feed it all to a machine, and then the machine can do those calculations on the fly. So that's kind of what you're talking about here, where at the end of the day, we're learning that having more data available is better than trying to take something that was never meant for us to understand and letting something that was built to understand it, and then make it available to us in a way that we need it. So it's like I'm curious if this metaphor works, but it's almost like taking some dirty water and instead of like shoving it through a water filter and then coming out the other end with that clear water that we get to drink, it's just like it's dirty water and then it's clear water and we get the clear water and we don't need to worry about the process in between that took to get it to where we want it. Does that work?
Yeah, I think so. I would add a little. I would extend the metaphor a little bit.
Let's do it.
You have this dirty water, and people who come to it some of them want to drink. Mm-hmm. And you give them a filter that filters everything out, all the impurities out, and they get water to drink. But other people come and they say, no, well, I'm looking for flecks of gold in this, and I don't care about drinkability. Give me a different filter. And we've learned how to make lots of different sorts of filters. We're getting better at it all the time. So here's the gold. And somebody else comes along and says, well, I want salt. We need salt or whatever. And somebody back in the planning process said, you know what? I understand. We're going to have this big pool of water and people are going to filter what they want out of it. And that's great. We'll get more value out of the water. I mean, it's just good business sense. But, let's take the arsenic out. Okay. I mean, nobody wants arsenic. Okay. Let's just filter on the way in. Let's filter the arsenic. And they do. Mm-hmm. And it turns out in 100 years, we are facing, because of our advanced chip technology, for implants, that the one chemical we really need is arsenic. And we filtered it out. Oh. So one of the lessons here, and I think one of the things that the internet is teaching us, as well as machine learning, is there's a price that we pay for the age-old strategy of strategies that we followed, which is to try to anticipate what we're going to need or what other people are going to need from us. We try to anticipate it, and then we do the prep work, so that's what's going to be available. So if you think that if you're Paleolithic times and you think there's going to be you're going to go hunting tomorrow and you think that you're going to encounter, I don't know, a woolly mammoth, you're going to anticipate that, you're going to prepare for it, and if you do it right, you're going to have the spears and everything's going to be okay. But there's also a pretty good chance you're not going to come across any woolly mammoths, but there are going to be a whole bunch of large edible birds that you are not prepared to hunt because you made wooden spears, which don't work on them. This strategy, and if the problems with it are tens of thousands of years old, it's made sense until things went digital and became networked. But in the digital age, which is increasingly both where we live, but also is giving us our ideas about how the world works. It turns out that we succeed frequently by not anticipating, for holding back. And A/B testing is one example of this. Right? You don't try to figure out, well, this one model should be on the left with a green background. You say, well, I don't know. I'm not going to anticipate. I'm going to try out two versions. And we see this all over the web. A lot of what's most exciting about, the internet, what's most exciting about the internet is, in fact, stuff that purposefully holds back from anticipation. Open platforms, for example, which we now largely take for granted, by which some company or organization builds its product, but also opens up a platform so that people can use those resources and do what they want, what they've imagined, or what their users need by building on what you've created. In the book I talk about, Slack happens to be a really good example. It's a pretty great piece of software, widely used. And they have an open platform that allows any developer in the world, anywhere, to alter and build upon Slack to do things like add new functionality that maybe their users need that nobody else, only a niche market needs, and Slack's not going to address, or to integrate Slack into the complex workflow of their own company. And that is incredibly valuable both for the users, but also for Slack. It makes Slack now capable of being part of virtually any workflow that has a digital component, which is, say, basically all of them at this point. But when you put out an open platform, you are implicitly saying, we cannot anticipate all the uses to which you might put our software. We just can't. And even if we could, we couldn't afford to build it all. And so let's not try to anticipate everything. Let's put it out and see what the world does with it. Yeah. And let the world add value to our product.
Yeah, so I actually want to dig a little bit more into those open systems. But first, we do need to take a break. So excited to have you here with us to talk about everyday chaos. David Weinberger is here, and we're talking about giving in to the chaos. But first, I want to tell you this episode of Triangulation is brought to you by ZipRecruiter. Now, hiring is a bit of a challenge. There are loads of people out there, and you're looking for a way to find the right person. I mean, there are multiple job sites, there are stacks of resumes, you've got confusing reviews, there's everything that gets in the way. But today, hiring can be easy, and you only have to go to one place to get it done. It's ZipRecruiter.com/triangulation. Now, ZipRecruiter is going to send your job. You go and you post your job onto the ZipRecruiter site, and it's going to go to 100 of the web's leading job boards. But they don't stop there. With their powerful matching technology, sounds a little AI, sounds a little machine learning. ZipRecruiter scans thousands of resumes to find people with the right experience and invite them to apply to your job. As applications come in, ZipRecruiter analyzes each one and spotlights the top candidates so you never miss a great match. See, you're not having to do that anticipation. You're letting the machine take care of that all for you so you can find the right applicant for you. ZipRecruiter is so effective that 4 out of 5 employers who post on ZipRecruiter get a quality candidate through the site within the first day. So it makes it so simple to hire. You're not going and looking at every single one of these 100+ job sites and trying to find the right candidate and filter down to the right one. You let ZipRecruiter take care of that for you. You put in the information. This is the person that I want. This is the type of skills that I'm looking for. This is what I'm looking to hire. This is all the information that the machine needs to know. ZipRecruiter is going to take care of the rest of it for you and get you your candidate. Now, right now, you can go as a Triangulation listener to try ZipRecruiter for free at our exclusive web address. That's ZipRecruiter.com/triangulation. You'll be showing your support for this show and ZipRecruiter by going to ZipRecruiter.com/triangulation. Once again, that's ZipRecruiter.com/triangulation. ZipRecruiter, the smartest way to hire. Thank you, ZipRecruiter. All right, so this is the part where I want to get more into open systems. Again, we have David Weinberger here talking about everyday chaos, and we were just kind of talking about how open systems allow for applications, in the case of Slack, as you sort of mentioned before the break, to not have to worry about anticipating how its customers would use the technology. I would like to think that the big company that a lot of people have heard of, Apple, they made the technology, they eventually made the App Store available, and they gave the developers the tools needed. And, I'm sure that Apple, to be a little crude, didn't anticipate that there would be a market for fart apps. But that very small market that existed was provided for because of the open system that they had available. So there's a little bit of chaos involved in fart apps and the ones that surround those, I'd say.
I actually think it's a good example. I mean, so Apple's a tough example because a lot of its value comes from the way in which it closes its system, and has such tight control over it that they can tune it and make it Apple-y and all the rest of it. And there's obviously huge advantage to end users in doing that, and also some costs. The iPhone was not the first phone that included the elements that we now associate with the iPhone. Mm-hmm. What made it successful, above all the other integrated attempts, was the fact that it had an app store. And the app store was a relatively open, it's still a curated place, but a relatively open environment in which the functionality of the phone could be extended by anybody. And I think fart apps are a really good example. I mean, they're silly and stupid and crude and all the rest of it. But we know that people wanted them for whatever reason. I think, variety of reasons why people want fart apps. That's really unpredictable. I think it's really unpredictable that would have been an early killer app on the on the iPhone. But that's the point. Apple did not have to anticipate. They didn't have to say, okay, now what's really going to drive this app store thing? What can we provide that's really going to open it up? No, let's we don't know. Let's see what happens. And it's going to be fart apps. It's also going to be some really pretty serious apps that they didn't anticipate. And some they did, I'm sure.
Yeah. And one of the examples that you give in the book is talking about the virality of certain videos and how you talked about the Ice Bucket Challenge, which reminded me that there's a video of me online doing the Ice Bucket Challenge, and all of these other charities and companies and all these people came out with their own type of challenge, and they just didn't take off. And it could be something as random as, like you said, the sunlight peering in over the person's shoulder when they saw the video that caused them to be, I mean, there are just all of these factors, and it's not something that we can predict. And there's sort of no explanation for why that one took the win. Although this is what's curious to me. There have to be at least hundreds of people out there whose job it is to predict what makes that video successful and then go to a company and say, okay, we're going to do the exact same thing. Is it we're just humans trying to give explanations to things that don't have explanations?
We're really twisty, human psyche. We got 100 billion neurons and 100 trillion connections, and that's a lot of twisty little triggers. Just the human metabolism, just the body. Forget the neurons in our brains. The human body's metabolism is largely inexplicable to us at this point. I mean, we know some stuff for sure, right? But even basic stuff we can't figure out. That's why there's not a single way that we know how to diet and lose weight, or exercise and lose weight, or live to old age, or avoid diseases. The metabolism is unbelievably deeply connected, lots of little pieces and factors, and there can be cascades of them that are set off by a single butterfly, so to speak. Or life is. So I'll give you an example. Not of either of those two things. So I've been a marketing guy for many years in my past, and I would more than once I've run into the situation where usually a CEO will say something like he's giving, usually it's a he back in those days, sorry to say. So he'll say, okay, new marketing team, great. So here's what I want. You know how New York has I Heart New York? And that's just so fantastic, and it revitalized the city. And Vegas has what happens in Vegas stays in Vegas. And that changed everything for Vegas. I mean, that's so great. Just 5 little words. I don't know how many words. That's what I want. Come up with that for me. And the problem with it is not that the people in the room are too stupid. They weren't smart enough to have come up with I Heart New York or everything that happens in Vegas. It's that it's unpredictable. The people who came up with that, I'm sure they were very smart, but they didn't know that these two phrases were going to define and revitalize cities. I mean, they hoped, but they had no idea. Those phrases went viral. There was something about them. Something, or actually many things.
Right.
And about the time, right? So the Ice Bucket Challenge, you're right, maybe the sunlight peering from behind the person, but it may also be that at that precise moment in American history, for some reason, for whatever the news, people were ready to hear this, and it became viral. And the next head of a nonprofit, I'm sure, said, that ice bucket thing, that was so fantastic. It was really successful. It raised a lot of money for a great cause. Mm-hmm. Do that. Just come up with that. How hard is that? I mean, it was an ice bucket. It was nothing. Just come up with that, okay? It's like I Heart New York. And the problem is that you're dealing with enormously complex systems that cannot be fully understood or predicted, or else everybody would have their own ice bucket challenge and everybody would be,
I feel like with that, we can almost look to if someone wants an example of chaos theory or everyday chaos at work, we can look to all of those challenges that the young folks do. Like I can remember doing the Chubby Bunny Challenge where you put marshmallows in your mouth, or the one where you, for some god-awful reason, drink a gallon of milk in like 10 minutes. And then because our body can't process that much milk, it's a bad deal. And then horrible things like the Tide Pod challenge, or I mean,
even the cinnamon challenge.
Yeah, the cinnamon
right?
challenge. I'm ashamed to say I may have tried, and it's just like, why did we do that? Why did it take off? Especially because, you know, with the ice bucket challenge, someone could make the argument that it had a lot to do with the fact that it was for a good cause. There's no good cause involved with trying to eat a tablespoon of cinnamon, and yet. And it's fascinating that it took off, and I'm sure, like we've kind of talked about, there are people who are analyzing it and trying to understand it. And I guess, you know, part of this book is kind of saying some things just aren't meant to be understood by us, and that might be one of them.
Yes, no, for sure. You know, so I want to go back to Halley's comet, who was trying to figure out what the trajectory of this possible, what he thought was a comet, he's going to try to project when it's coming back, and that requires it's passing between Jupiter and Saturn, and all the bodies are moving. At every instant, they're sort of changing their own trajectories, and you've got to calculate all of that, and it's really, really hard. But the idea was, there are simple rules for gravitational pull, right? This is Halley was Newton's best friend insofar Newton had friends. Not a very social guy. Probably would not have been big on Twitter. Halley was a supporter and friend, very important to Newton. And it was Newton's laws that enabled Halley to do the calculations, or to get actually other people to do the calculations. If you know where body is here, how it's moving, you can figure out in the next instant where it's going to be. And the laws are understandable obviously by humans. You can still get really complex situations, as when you have multiple bodies moving through. It was only with the rise of chaos theory in the early 1970s. So when somebody says it was only when, almost certainly he or she is going to turn out to be wrong. Nevertheless, I think I'm committed now. For the first time ever in human history, we began to realize that even if the world is ruled by a handful of simple laws can produce enormous complexity. And one of the real moments in the recognition of this truth was a game called the Game of Life that was invented in 1970, actually 1969 maybe, but we'll say around then, by a mathematician. Which consists, if you've taken computer science courses or whatever, or even if you haven't, you may have come across it. It's a grid, like a grid, like a Scrabble board or something, in which you randomly place markers just to kick the thing off. And there are like 5 different rules for what the next turn will look like. So the rules have to do with what the immediate squares surrounding each individual square. If there's more than 3, then the square in the middle becomes unoccupied. If there's 2, then it's occupied. It's like 4 or 5 rules. And the rules are really simple. It turns out when you do that, and you do it over and over, so you take one turn and some of the squares flip, and you do next turn, apply the same simple rules, some of the squares flip. It's completely unpredictable what the patterns will be. If you want to know what's going to happen, you start off with the board with squares 1, 3, 9, and 22 filled in or whatever, and you want to know what it looks like at move 100. Literally the only way to get there is to do the 100 moves. And you will end up frequently with just sort of chaotic, static-y looking stuff that doesn't have any obvious pattern. But sometimes, totally unpredictably, you will get something that looks like a bird flapping across the board, or there are guns that fire filled in squares at other things. Very simple rules that generate enormous complexity. Chaos theory certainly has taken this up around the same time, and we're getting used to it. So even if there are these simple rules, doesn't mean the universe is simple or that we can understand it. It means that it can generate mind-boggling chaos that we can't possibly predict more than one move ahead.
Now, there's one thing that I have to talk about, because this has always been a fascinating thing to me from the moment that I learned about it, and that is the life of the humble chicken sexer.
Sure.
You sort of speak about, I kind of like the connection between learning to be a chicken sexer and how machine learning at its heart kind of works, where we don't really know how to tell the difference. We don't have if you ask a chicken sexer how they sex a chicken, they can't explain it to you. And
you might want to explain what sexing a chicken means.
Yes, that is important. That is very important. So when chicks are babies and they're trying to tell if the chick is male or female, the female obviously will produce eggs and the male just eats your feed and is maybe not worth keeping around, sadly. So they have people who can tell the difference between the two. It's not a process that's super simple and can be explained, but the way that they learn how to do it is a person who is a professional chicken sexer has some folks who are learning how, and they guess, and then the professional chicken sexer is like, you were right, you were right, you were right, you were wrong, and then they just somehow figure out how it works, which is just wild, and it is not something that we understand really and can't be explained, and yet we accept it. And that is kind of what we do with machine learning when we're teaching it. For example, you talk about teaching it manuscripts or to be able to understand manuscripts. And
to recognize, scan in letters from old manuscripts and figure out what the letters, identify the characters. Yeah,
which it starts with humans properly identifying, and then goes from there, and it just opens up the possibilities, and we don't necessarily have to understand what happens in between, because the outcome is what we're after in that case, whether it be chicken sexing or otherwise. But I don't know. I just think that's a really good comparison.
Good. Me too. So the chicken sexing problem is one that has some traditional philosophers have taken as interesting, as an example of something, because here's a case where we get knowledge, and we know that it's knowledge in some sense because people get trained at it and they get enormously accurate and fast at it, right? I mean, there are people who can do hundreds of determine the sex of hundreds of chickens in an hour with making basically no mistake. So there's something like knowledge going on there. We cannot point to the features of the chicks that are telling the person why it's male or female. The males get ground up alive. It's really horrible. Some of us have been vegetarians for 40 years. It did not make me want to eat chicken again. So and machine learning can be like that. So I want to be clear. Often we do know more or less, at least some of why machine learning is making the choices that it does. But in the interesting cases, as of now, we don't. Mm-hmm. So machine learning can be like that. I think the thing that bothered philosophers is that philosophers, I'm sorry, I am not one, that philosophers want knowledge, things that we know, to be justifiable and explainable. It's not enough that you say, I have an intuition who's going to win the horse race. You have to, for it to be knowledge, even if your intuition is right, for it to be knowledge, you have to be able to say why. You need some sort of justification for it, an explanation for it. And these chicken sexers clearly making correct, truthful assertions, but can't tell us how, which is just weird in itself. But I think the real question is life more like the philosophers think, or is it more like the chicken sexers think? When you learned what a bird was when you were very small, you weren't told, well, here are the 5 characteristics of a bird. They have wings and feathers. They fly. They have beaks, and I don't know, whatever it is. If you go back to Aristotle, it's always one distinction between other birds and things and another distinction between what isn't a bird. Uh-huh. And so you're nice logically. But that's not how you learned. And if you go backwards now, and I ask you, it's a bad example. Let me, so let's instead say it's what a vehicle is, a motor vehicle. Right. Nobody defined motor vehicle to you. They gave you some examples, or you picked up the examples. And if I were to ask you what a motor vehicle is, you may or may not be able to give me a definition. I'm not sure that I could. I think I'd struggle with it. And then if I ask you, is a surfboard a vehicle? Are skates a vehicle? Is a parachute a vehicle? You're going to say, sort of, kind of. I mean, And you won't be bothered. You don't feel like, now I have failed the vehicle test. It's that the world doesn't sort itself out into these nice categories, which we learn by definition. I think we learn much more like chicken sexers do in almost every field, in every case, and throughout our lives, than we do like we have thought we should under our classic and traditional understanding of how knowledge works. We can't always articulate what we know. Most of what we know, we can't articulate exactly, and we argue about it. Is Fox News journalism? I mean, there's a political point to that, but sort of isn't. It's like asking, is Big Bird a bird? Yeah, I mean, kind of. It's a terrible example of a bird, but it's something. It's not an elephant. It's not a letter opener. It's not a barbecue. Life is way more like that, where we don't start with clear definitions and clear explanations. Sometimes we can fetch them up, but that's not how we organize the world. So one of the things I think machine learning and AI is freeing us to accept is that we don't work by clear definitions, by a model of the world that's precisely defined. Here is what matters. Here's how they No, it's not how it works. It never was.
Yeah, I would even argue that our ability to read is in some way based on that sort of gray area, because an R to me doesn't necessarily look like an R to you, but we can both recognize that character across thousands of different fonts and things like that. And so over time, we start to learn what those characters represent. And there, of course, is a little bit more focused education on what makes an R. But over time, like I can read somebody else's handwriting, except for my doctors, of course. No one can read their doctor's handwriting. But other than that, we can read each other's handwriting, even though it's very variable. Very variable. I could talk to you all day about chaos theory, but we are running out of time. I want to ask you something that you said earlier. You said arguably the most important AI is the neural network. Would you like to tell us a little bit more about what a neural network is and why you feel like that's one of the most important forms of artificial intelligence?
So you've got AI, as I was just saying, most of this is loosely defined. There's stuff that's clearly AI, stuff that isn't, stuff in the middle. So you have AI, then within that you have a branch called machine learning, and within machine learning there's a branch called deep learning. And deep learning certainly uses neural networks. It depends how you want to define it. So let's just say deep learning, because that's the interesting cases. Because in deep learning, the neural networks are really, really complex, tend to be. And that's where you get both really mind-blowing effects quite often, and also where you're more likely to run into the can't figure it out issue. So I point to neural nets for two reasons. First of all, that's where a lot of the most exciting, interesting, and mind-blowing work is being done. And if you just read a news report or something about a new AI that's doing something impossible, very likely it's a neural network. That's one reason. It's just sort of factually, that's where it's happening right now. The second is that, for me, that they are the epitome of the opposite way of approaching how to understand the world. So traditional programming, where you know what the factors are, what their relationships are, and you build the model and you give it to the computer, that is completely in line with thousands of years of Western thought of how we should proceed. Find the big factors and the rules that connect them. Neural networks are what you get when you, at least in some instances, when you don't follow that approach, when you instead say, you know what, let's just pour in data and let's let the model be as absolutely as complex as possible, millions and millions of pieces. It's with neural networks that you run directly often into the fact that it works, it does things better and some things we never thought would be possible. But we can't figure it out. The computer scientists can't figure out how the thing is working, and the domain specialists, the doctors, can't figure out how it's making these diagnoses. There's controversy. I think many people who think that this is a solvable problem, at least to one extent or another. It's a huge amount of work in trying to make these systems intelligible to people. But at least for now, and as a non-expert, I think my bet would be that it's going to keep getting more and more complex and more inexplicable. At least for now, there are some systems that work. Got to throw up your hands. Don't know. Can't figure it out.
And we don't have to. We can let go and let chaos theory.
Often, but not always, because there are questions of bias.
Yes.
Okay.
There it is.
Yeah, no, it's really important.
I think that's, we got that checked a couple times now. So no
it's
tweets.
Not just, and it's not just, it's not just protecting myself from tweets. It is a really serious problem.
Yeah.
I'm going to take one sentence, if you don't mind.
Absolutely.
Machine learning learns from data. That data, if it has anything to do with humans and how we treat each other, almost inevitably reflects the most pernicious, awful biases in the culture. And unless steps are taken, machine learning will not only reproduce, but very likely amplify those biases. So it's a really serious problem.
Well, let's briefly touch on then. There was, I think it was Microsoft who came out with this machine learning bot. And I can't remember what her name was, but they called it a her. And for a while, you could communicate with it, and it would just normally respond back. And then a bunch of people fed it a lot of very racist things, and then the bot itself became racist because that was the data that was sort of plugged into it. But that is a more obvious and clearly defined sort of understanding of how that bias can take place. Tay, thank you. Tay was the name of the robot. But that is, a clear example. And kind of what you're talking about, I think, is a little bit more of the things that we don't necessarily see, because we are looking at these small pictures. But if you feed it a trillion data points and there is some inherent bias in those things, then that's where we have this issue of different types of bias playing a role in determining or not determining, correct?
Yes. So I'm not sure I'm thinking of the same example, but I think it was I'm not sure who, fed in tweets, and within an hour, the bot had become full-on racist. Mm-hmm. It was both funny and horrifying. In that case, you can spot the racism instantly, right? I mean, it's just being a racist. That was really easy to see what had happened. It was horrifying. In the case of some system that's being used for figuring out what's the most effective bus schedules and routes in the city, or something evaluating loan applications, or really well-known and quite distressing examples in the judicial system of machine learning being used to assess bail and sentences.
Yes.
The racism may be far more hidden. And if you can't know how the system came up with its decisions, it may be very hard to discover the racism that is embedded in it. So lots of people are working on this, thankfully. But it is a very, very, it is machine learning's original sin in that it's connected right to the essence of machine learning. The essence of machine learning is it learns from data. Mm-hmm. And,
and I suppose
it'll end up racist unless you go ahead.
Right. I was just going to say, and I suppose that's why we can count on things like weather patterns to sort of be a good example of how machine learning and we interact every day. I think even in the book it was described as sort of going from, I don't know, like a Minecraft 8-bit video game to being able to zoom in and see the sweat rolling down a character's face in terms of the complexity that was added when we threw in those deeper learning systems to predict weather. And with those, we're looking at weather patterns, and we don't necessarily have to worry about any of that bias getting in the way.
Oh, but you do.
Oh, but there's still some there?
Well, I don't know that there is, but you need to worry about it. I'm going to give you an example. I'm making it up. I don't know if it's real, but it's easy to imagine a case in which the data for developed nations is far richer than data for less developed nations. Fewer sensors, worse communications, all those sorts of just unfortunate facts of life. So it's plausible to worry that weather predictions are going to be more accurate in wealthier parts of the world. Now, that's not flat out racism, but it can have enormous effects on, weather forecasts are really important, as we know in hurricane seasons and the rest of it. So there is a type of inequality that and a type of unfairness that can arise even in something as global as weather.
Wow. David Weinberger, Everyday Chaos. It gives me hope that, you can sort of stop me in the middle of that and say, now we do have to worry about it in that case too, because I'd like to believe that the folks that are creating these systems and making these, at least in some cases, Microsoft, at least in some cases, are paying attention to the ways that these can be used improperly or can lead to bias. But I want to thank you so much for taking some time today to talk about your book, which folks, you can get on pretty much anywhere, anywhere where fine books are sold. It's available, and you can head to the website there. There's a buy now button, and it's been out since May. So yeah, you can definitely get your copy to check it out. I got to tell you, I love how excited you really had a lot of energy about this topic, and hearing these little stories and these little examples and things adds to the richness of this book, which I really enjoyed, because it sort of was an eye-opening experience for me in the sense that it's giving over to that. My desire is always understand and explain things, and sometimes we just can't. And in that case, we almost can come up with better results in the end. So that was, I'm learning one day at a time, embracing chaos.
Me too. Great talking with you. Thank you.
Yeah, thank you so much. And people looking to follow you online, they could do that over on Twitter, yeah?
Yes, D. Weinberger.
All right. Thank you so much for being here. And folks, that's going to do it for us. It is Everyday Chaos. Get used to it, because it's out there. Triangulation records every Friday at 2:30 p.m. Eastern. That's 11:30 a.m. Pacific, which I'm not doing the calculations. The machine is doing that for me, is 18:30 UTC. You can, of course, follow along live by going to twit.tv/live. Thank you to those of you in the chat who were there with us. Appreciated your mentions of Dr. Malcolm, who was all about chaos theory in Jurassic Park. And of course, don't forget to subscribe to the show at twit.tv/triangulation, where you can get every episode as it comes out and hear from the best and brightest minds talking about the most important topics in technology. All right, folks, that's going to do it for us.